So, a review of solving polynomial equations. There actually aren't any equations here, but finding zeros. So you'll find zeros by factoring and using the rational zero theorem. Alright, so factoring. So step one is factoring because it's usually easiest. But we have, wow, all the stuff here. So let's see. When you factor, first thing you look for is the greatest common factor. After you do that, you count terms. There's two terms, there's special patterns, and you can see them here. There's difference of squares, sum of cubes, difference of cubes. So those are just little formulas that you can use if you have two terms. If you have anything else, it's just two terms, and you've already done the greatest common factor, that's it, you can't do any more. For three terms, it's your basic trinomial. You put the two sets of parentheses, we'll say what times what makes the first thing, what times what makes the last thing. That's kind of a guess and check. And then four terms is grouping. Do do that, you look at what's left and see if you can factor any more. After you factor to find the zeros, or if you're solving an equation, make each factor equal to 0 and solve for x. So you can see I have four examples here from your worksheet. So let's start with the number 2. We need to find our greatest common factor first. So I see that 16 is 4 times 4. So that means both of them have a 4 and both of them have an x. So I could factor out a 4 and an x, leaving, well, x to the third, if I factor out an x, leaves me x squared, and the 4 is gone. If I factor out the first 4, the other 4 is still there on the 16, and I factored out the x. And then we try to factor more. Oh, I see two terms, the x squared plus 4, but that's plus. It's squared and plus. We don't have a sum of squares. We just have a difference of squares, so that's not factorable. But I could take each factor equal to 0. I'm not going to take the 4 equal to 0 because 4 doesn't equal 0. But I could take x equals 0, and I could take the x squared plus 4 equals 0. That would be x squared equals negative 4. Then take a square root. Remember, when you do a square root, you put plus and minus. And the square root of negative 4 is, well, square root of a negative is I, and the square root of 4 is 2. So you have three answers, 0 and plus or minus 2i. Let's try number 4. Again, look for a greatest common factor, which is a 2. The other one doesn't have any x's. 16 is 2 times 8, so you see there was a 2 in both. If I factor out the 2, I'm left with 8. And you say, oh, okay, try to factor more. Well, this is x cubed and it's plus, so it might be the sum of cubes. Well, let's see, is 8 a cubed? Sure. 8 is 2 cubed. So that means A is the x and B is the 2. So our answer could be, the formula is, I'm looking at this one right here, A, which is x, plus b, which is 2, a squared, which is x squared, minus ab, so that's 2x, plus b squared. Well, b is 2, so 2 squared is 4. And there we go, it's factored. Now, if we wanted to find the zeros, so I'd take each of those equal to 0. So I'd go x plus 2 equals 0, and I'd go x squared minus 2x plus 4 equals 0. Well, out of x minus 2 from the first one, x equals minus 2. For the second part, though, we can't factor that anymore. I mean, you could try, but I'm going to guarantee you can't. Whenever you do that difference of cubes or sum of cubes, you can't factor the trinomial anymore. So we're going to have to use the quadratic formula. So that's x equals negative b plus and minus the square root of b squared minus 4 times A times C all over 2 times A. Well, that's 2 plus and minus the square root of negative 8, if I put it in the calculator, over 2. Oh, but wait. Negative 8, the square root of 8, 8 is negative 4 times 2. So I could, the square root of negative is I. The square root of 4 is 2. And I have the square root of 2 left. Well, the 2's will cancel, so it would be x equals 1 plus and minus the square root of 2, I. So number 4, there's the factored part, and the zeros are negative 2 and 1 plus or minus 2i. So again, the 2's canceled. You can cancel with everything on top with something on the bottom. You can cancel out. Let's clear the ink and try number 7. All right, number 7. Look for a greatest common factor first. Oh, notice the 6 is 2 times 3, and the 8 is 2 times 4. So there's a 2 in everything. So we can start by factoring out the 2. If I factor out the 2, I have a 3 left. Factor out the 2, I have a 4. Try to factor more. Well, that's 3 terms. So it's 2 sets of parentheses, and we guess and check. And we say, what times what is x squared? And what times what is negative 4? Well, you might want to try negative 2 and 2. That makes negative 4. But then if I add these, I'll have negative 2x and 2x makes 0. But I really will need it to make negative 3x in the middle. So that didn't work. So let's erase that and try again. All right, so what else times what else makes negative 4? Well, how about negative 4 and 1? Does that add up to make my negative 3 in the middle? Yeah, negative 4 plus 1 is negative 3, which is the middle. That's what we want. So now we're going to take, so that's factored. To find the zeros, we'll take each factor, not the 2, because 2 doesn't equal 0, equals 0, and solve for x. So I'll get 2 equals, or x equals 4, and x equals negative 1. All right, let's jump down to number 8. Look for a greatest common factor. The first thing only has x's, the last thing only has numbers, so there is no greatest common factor. So we can factor by grouping. So we group 2 by 2's. When there's a negative in the middle, make that inside the group and make it a plus a negative 2. Otherwise, if you put the parenthesis between the negative and the 2, you'd have to distribute the negative, which would make it plus 10, but it's not a plus 10, it's a minus 10. In each group, remove the common factor. For the first group, that would be x squared. The second group, my greatest common factor is negative 2. Negative 10 is negative 2 times 5, so if I get rid of the negative 2, I'm left with a 5. Repeat, now we have a greatest common factor. We've got an x plus 5 that we can factor out, so let's factor out the x plus 5. Leaving, when those gone, I have x squared. When that one's gone, it's minus 2. Well, that's 2 terms. We could try factoring that. It's squared, it's a minus, it's a difference of squares, except for 2 is not a square. So there we go. That's factored. To find the zeros, you set each factor equal to 0. And you solve for x. So I'll get negative 5. On the other one, I'll get plus or minus the square root of 2. Remember, when you take a square root, when you solve, you have to put plus and minus. If factoring doesn't work, we have to use the rational root theorem, which I call the p's and the q's. So what you have to do is list the p's and q's. P's are factors of the constant term, in this case the 1. Q's are factors of the leading coefficient, in this case 3. All right, so I'm going to put this up at the top where I have some space. So p's are factors of 1. What times what makes 1? Well, just 1 times 1. Plus and minus, because it would be positive 1 times a negative 1, or negative 1 times a positive 1. Q's are factors of 3. What times what makes 3? Well, 1 times 3, or negative 1 times negative 3. So we want all the p's divided by q's. So if I do 1 divided by 1, 1 divided by 1, I get 1. Or I could do 1 divided by 3, get 1/3. So there's my p's and q's. It's not our answer, it's just possible zeros, because we have to figure, kind of guess. Looking at a graph, if you have a graphing calculator or a provided graph like I did here, we look for an x-intercept, and I see 1 right there. Is that on my list of the p's divided by q's? It's a negative 1. Sure, negative 1's right there. So we're going to do synthetic division with that negative 1. Bring down the 3, multiply the negative 1 with the 3, add, multiply the negative 1, add, multiply with the negative 1, add, multiply with the negative 1, add. All right, that's a 0, right? That means negative 1 is a 0. So there we go. That's one answer right there. How many should we have? Oh, yes. That tells us we should have 4 answers. The degree is 4, so we should have 4 answers. Well, now you look at the depressed polynomial. A depressed polynomial will be 3x. It was to the 4th, but we divided by one of them, so it's x cubed. It's 1 less power. And then fill in the rest of the x's. So that's my depressed polynomial. Is that a quadratic? No. So we're going to repeat. We need to find another x-intercept. How about right there? Well, it's not 0 or 1. It's between 0 and 1. Do I have a p over q that's between 0 and 1? Sure, I've got 1/3. So we're going to try synthetic division with 1/3. Notice I'm using the depressed polynomial. You want to do that. You've got to use the depressed polynomial. Bring down the 3 and multiply. 1/3 times 3 is 1. Add. 1/3 times 0 is 0. Add. 1/3 times 3 is 1. Add. Look at that. It's another 0, so 1/3 is a 0. All right, that was x cubed. It's depressed, lost a power. It's x squared plus 0x plus 3. Is that quadratic? Yes, it is. So now I can take that equal to 0 and solve it pretty easily. We could subtract the 3, divide by 3, and square root. Don't forget the plus and minus. Oh wait, what's the square root of negative 1? That's right, it's I. So the rest of my zeros are negative. Plus and minus I. So our zeros are negative 1, 1/3, and plus and minus I. See, just looking at the graph, you wouldn't have picked up the plus and minus I. That's why you have to go through all the synthetic division. All right, if you want it in factored form, it's in the form x minus k. So that'd be x minus a negative 1, x minus 1/3. And usually you don't do it with I, so we could go back up to here and use that as the last factor. So minus a negative is a plus. Notice here, though, in this one I have a 3, a common factor of a 3. Let's factor that out. And then notice here I've got a fraction. But what if I multiply the 3 with that? I'll have 3 times x and 3 times a third. And there we go. That is the factored form. All right, you have 5 more problems. Why don't you try those on your own, and I'll see you tomorrow.